Good morning, class. We are looking at statistics practice test number 1, module 1, covering chapters 1, 2, 3. Here's chapter 2. Exploring data with tables and graphs. So chapter 2, exploring data with tables and graphs. Given the FDT, frequency distribution table, sometimes they just call it frequency distribution, sometimes they call it frequency table. So FDT for short. Answer the following questions. The number of classes in the table is. So what do we have here? This is one class, the class containing the age group from 11 to 20. There are 5 of them. The second one, the group containing the age group from 21 to 30. There are 6 of them, so on and so forth. So we have 1, 2, 3, 4, 5. 5 number of statistical age groups defined. Number of classes. What's the class width? This distance is called the class width. How do you calculate it? UL, upper limit, minus LL, lower limit, plus 1 unit. Now, it's important to understand 1 unit. It depends on the unit that is being used. It's in thousands, or it's just unity, or 0.1. So 20 minus 11, or 30 minus 21, or 40 minus 31, and we add 1. Becomes 10. So notice, if you go column-wise, 21 minus 11 is 10, 31 minus 21 is 10, 40 minus 30, 50 minus 40. So if you want to go column-wise, just pick any 2 consecutive classes and do it. If you want to go in one row, then the upper limit, these are the upper limits, these are the lower limits. And you have to add 1. So upper limit minus lower limit plus 1 unit, or difference of 2 consecutive lower limits or upper limits, i.e. 21 minus 8. The midpoint of the 4th class. By definition, the midpoint is the sum of the limits divided by 2. So the lower limit and upper limit, they add them up, you divide by 2. That's the general case. So for the first one, 11 plus 20 divided by 2. For the second one, this 2. For the third one, but they're asking for the 4th class, 41 and 50. So lower limit plus upper limit divided by 2. Add these 2 numbers. 41 and 50, 91 divided by 2, 45.5. The lower boundary of the 5th class. So what is the lower boundary? So in general, if you want the lower boundary of any class, you look at the upper limit of the previous one, the lower limit of the same class, add them up, find the midpoint. That simply means 50 plus 51 divided by 2, which is 50.5. 50 plus 51 divided by 2. Midpoint of the upper limit of the 4th class and lower limit of 5th class. That's how you find the boundary for the 5th class. The upper limit in the 1st class. So these are the upper limits. For the first one is 20, second one is 30, so on and so forth. So since we want it for the 1st class, obviously it's 20. Upper limit is 20, 1st class is 11 to 20, upper limit would be number 2. The sample size, just the frequency, add them up. We call it N equals summation of X. Add these numbers 5, 6, 9, 11, and 4. We get 35. So we are going over a lot of stuff in this section by looking at a couple of simple examples. We're going to continue with the same question. We are not done. the relative frequency of the first class, or for short, RF, is the frequency divided by n. That's the definition. So if you recall from the previous page, first this one is given, this one is given. Now n is 35, class width is 10. So f over n. For the first one would be 5 over 35, second one 6 over 35, so on and so forth. So 5 over 35 and 1 over 7. By the way, you have to put it in lowest term in anytime you're dealing with a fraction. So the answer is 1 over 7. If you want to go with decimal notation, you have to carry a lot of decimals. You want to pay attention to how many they ask you. And of course, if they ask for the percentage, you know how to change from fraction to decimal to percentage. So you move the decimal by 2 places, becomes 14.29%. Now, I'm writing RF for each and every one of the class. So this is 5 over 35, this is 6 over 35, 9 over 35, 11 over 35, 4 over 35. So this column, the frequency divided by n, one by one. That would be the RF, relative frequency. Boundaries are the midpoint between the upper limit of the one class and the lower limit of the next one. And we already found, if you recall, for this one, we said add these two, divide by 2. Now this 50.5 is the upper boundary. 50.5 is the upper boundary for the fourth class and the lower for the fifth one. So that's for both of them. So if you stick with that, 50.5 here, 50.5 here. We just write that and then, so we already have this, we calculated. Now, when it comes to boundaries, everybody, then all you have to do, add the 10, which is the width. So if I add 10, I get 60.5 here. Over here, I'm going to subtract 10. I get 40.5 here. Same thing here, 40.5. I subtract 30.5. I put the same 30.5 here. I subtract 10. 20.5. I put the same 20.5 here. I subtract 10, and I get 10.5 here. So that's what we get. Let me erase my work. So we've already done that. I wanted to show you all the boundaries so that it's good to write them column-wise. Find the model class let me quickly remind you about the midpoints that we did also. Remember, for the first class, add these two, divide by 2, same thing for the next one and the next one and the next one. And so 11 and 20, 31, divided by 2 is 15.5. And then you don't have to evaluate the rest of them, just add the width. So if the first one is 15.5, keep on adding 10. The next one becomes 25.5, 35.5, 45.5, 55.5. So let's write the midpoints as well. And then the model class, by definition, the model class is the one with the largest frequency. And this one has the largest frequency by definition. So that would be class number 4, which is from 41 to 50, with the highest frequency of occurrence, which is number 11. What is the mode? The midpoint. So one more time. What is the modal class? Look at the highest frequency, 11. This is the class. Class number 4, which is 41 to 50. What is the mode? Find its midpoint. The following frequency distribution table describes the speed of drivers ticketed through a 30 miles per hour speed zone. Calculate the relative frequency. As you know, the relative frequency, we define it as f over n. So the first thing is to find n. So add these numbers, or these numbers, 25, 14, 7, plus 3, plus 1. N equals summation of x equals 50. Add them. That's the first thing we need to do. So if that is the case, the relative frequency becomes for 25 divided by 50, 14 divided by 50, 7 divided by 50, 3 divided by 50, 1 divided by 50. And of course, 25 over 50 is 1/2, 14 over 50 is 7 over 25. Always write it in its lowest term when you write it as a fraction. What percentage represents the speed of 53 miles per hour or less? So find 53 miles per hour. So 53 miles per hour. This is the upper limit of the third class and everything less than that. So that covers those three numbers. Cumulative frequency distribution of 53 miles per hour or less refers to the first three classes, right? 53, the upper limit of the third class. We want anything less than that. So all the way to 42 would be less than that. So we have those numbers. We can add those numbers, divide by 50, or just add these three numbers. So we have two choices. We say, okay, we're going to add these three numbers and divide by 50. Or we already have them here, add these three. Okay. And so what do we get here? 25 over 50 is 1/2 or 0.5. 14 over 50 or 28 over 100, 0.28, 7 over 50 or 14 over 100, add them up, 0.92. This happened to be exact, so it's not a big deal. Or as I said, just add them up in this fashion. What about the boundaries? Recall the definition of a boundaries. Boundaries are the midpoint between the upper limit of one class and the lower limit of the next one. So for example, if we start with this first one, let me erase my work. So we add this to divide by 2. You get 45.5. This would be 45.5 would be the upper limit of the upper boundary of the first class, lower boundary of the second. In other words, 45.5, add this to 45.5 belongs here and here, which is the, again, upper boundary of the first class. That means everything less than 45.5 belongs to the first class. Everything from 45.5 and up to the next one. Now, all you have to do, just add the width. And what is the width? The width is equal to 4. There are many ways to find it. You can say 46 minus 42, 57 minus 53, 61 minus 57, or you can say 45 minus 42 plus 1. So let me just write one of them. If you want to go with the same row, you get 45 minus 42 plus 1, which is if you want to go, let's say like so, you can say 58 minus 54 is. Now, why do we need the width? It makes life easier. All you have to do, subtract 4 for here, you get 41.5. Add 4 for here, you get 49.5. This one is also 49.5. Keep on adding 4 and you're done. Continue with the question. The following frequency distribution table describes the speed of the driver articulated as it was mentioned. Construct a histogram corresponding to the frequency distribution table. And again, reminding everybody of the boundaries. Now, when it comes to histogram, what happens along the horizontal axis? You can put the limits, you can put the boundaries, you can put the midpoints. And later on, we learned that for ogive, we must use the boundaries. So I'm going to put the boundaries here. Again, it is not a big deal. Either way is fine. So over here, the maximum number is 25. So let's just, on the vertical axis, we're going to put the frequency. So for the sake of argument, from 41.5 to 45.5, we're going to put 25. Okay, so it goes here. And then the next one is 14, goes down, so on and so forth. So it looks something like this, everybody. Now, what I want to add is this, finding the width from the histogram. If limits are given, the width is calculated as follows, and we do not add 1 as explained before. That's how the platform, the digital platform, my OpenMath works. So simply upper boundary minus lower boundary is always the case. Now upper limit minus lower limit from the histogram, you have to go that way. Okay, not with. Remember, if you're having this, it's 45 minus 42, and then plus 1. But if you happen to have it in this format, it's just the difference between the two. So in essence, we are looking at the same thing, but we are looking at the same question. We are preparing the cumulative frequency distribution, and then from there, cumulative relative frequency distribution and so forth. Now, what I like to do with the moment I see cumulative, that means the lower limit remains the same. If I want to go with the limits, I would write 42 to 45, 42 to 49, 42 to 53, 42 to 57, 42 to 61. Or you can say less than the boundaries less than the upper boundary of each class. Remember this class, the upper boundary is 45.5. So less than 45.5, less than 49.5, and so forth. So that's how you write the cumulative speed. Again, if you want to use the limits, you put 42 as the lower limit of each class because it's cumulative. And so what happens as far as the frequency, obviously the first one doesn't change, it's 25. But the second one, they add up because it's not 46 to 49, it's 42 to 49 or less than 49.5. So add these two numbers, 39, then add 7 to both of them and continue with this adding. So the first one is 25. The second one, 25 and 14 is 39. And now we add 7, we get 46. Now we add 3, we get 49. We get add 1, we get 50. Now, it's important to know in this column, the very last one must be always equal to n. If not, we have made a mistake. So What about part B? Relative frequency was defined as frequency over n. So cumulative relative frequency works the same way. So 25 divided by 50, 39 divided by 50, 46, 49, 50, each one divided by 50. Now, it's important to understand. The last one must always be 1 or 100%, depending upon whether they ask for a percentage or not. So cumulative relative frequency must be 1. The last one, cumulative frequency must be n, whatever the value of n is as the last. Now, same question, draw an ogive of the cumulative percentage distribution, reminding everybody this is from the previous page, this is from the previous page, and of course, at the bottom, we must put the boundaries. Now, you got to pay attention to this one. Sometimes they ask for cumulative frequency. You put those numbers. Sometimes they ask for the percentage. And if they ask for the percentage, that means you have to put the percentage accordingly. So you want to be very careful with your reading, everybody. And so over here, we start from 0%, we go all the way to 100%, even 120, just for the sake of argument, but we go to 100, okay, no more than that. The lower boundary of the first class corresponds to 0, just to give you an idea. And so this one corresponds to 0. This one, 61.5, corresponds to 100%. And then what about this? Now the upper boundaries correspond accordingly, okay? The upper boundary of each class corresponds to that number. So for example, 45.5 corresponds to 50%. So on and so forth, okay? 49.5% corresponds to 78%. Something like that. I'm going to erase my work again and the final result. Okay. So 41.5% correspond to 0, 45.5%, 50%, 49.5, 78%, and so on. And you connect them with line segment. Ultimately, it looks like a curve, but you connect them with the line segment. Using the OGI, find the percentage of drivers who drove 47 miles per hour or less. So we are going to locate 47 here, and corresponding to that, the number is the answer. So this is number 47 between 45.5 and 49.5, and that would be the answer. So number 47 is somewhere between 45.5 and 49.5 on the horizontal axis, which corresponds to approximately 60%. Therefore, 60% to 61% of drivers drove 47 miles per hour or less. So that's how we do it, everybody. Given the following sample, which represents the age of 40 tenured faculty at CSULB, n equals 40 ages. Construct a dot plot. Construct a stem plot, stem and leaf also. So what are they asking? Let's look at the definition. A dot plot is a graphical display of data using dots for relatively small data sets where values fall into a number of discrete values, categories. Data values are plotted as dots along a horizontal scale of values. Equal values will be drawn as a stack of dots. That is the definition. So what do we do first? First, we put this in order and we rank them from smallest to largest. The smallest is 32, the largest is 63. It makes it easier to deal with when we have it in that format. The first thing is to rank. Then we go with sort of a number line and we put number 32 to 63 roughly. We want to be precise when it comes to that. So over here, if you have 35, then this is 40, 45, 50, 55, 60, so on and so forth. So you locate 32 somewhere here, you put 1. Number 37, here you put 1. 39, you put 1. 40, you put 1 dot. And you 42, 43, 45, 46, you put 1 dot, you locate. Now, when you get to 47, okay, let's say somewhere here, then you put 1 and 2 dots. 48, 1 dot, 49, 50. When you get to 51, you put 2 dots. 52, 1. 53, you locate 53 and you put 1, 2, 3 dots. You stack. This is it. So that's the dot plot. So clearly the ages range from 32 to 63 years. Also, there is more tenured faculty at older ages. Look at more dots here, right? So more towards the end. So that's a very simple case known as a dot plot. Now, the next part is to go to stem plots, also known as stem and leaf plot. So what is that? Stem plots or stem and leaf plot display the data in order from smallest to largest. A stem plot, like a histogram, is a tool to help you visualize a quantitative data set. The name stem plot is because there is one stem with the largest place value digits to the left and one leaf to the right. We can see the distribution of data while keeping the original data values. So that's the concept. So what do we need to do? This goes from 32 to 63. So we're going to put 3, 4, 5, 6 as the larger digit, if you will, right? The tens. So in the 3 area, I see 32, 37, 39, and I have no more. So I'm going to put 2, 7, and 9. Then I go to number 4. Okay, I need 40 all the way to here. So I'm going to put 0, 2. First of all, this is the group. So I'm going to put 0, 2, 3, 5, 6, 7. And I'm going to repeat 7 again, 8, 9. And of course, the same thing for 50. I put 0, then 1, 1, 2. I put 3 threes, 4, 4, 4, 5, 5, 6, 6, 7, 8, 8, 8, 9, 9, 9. That's the largest. And I finish it with 60. The last one, I'm going to put 0, 0, 1, 1, 2, 3, 3. Again, the ages range from 32 to 63 years. Also, there is more tenured faculty at older ages.